Lecture we will be talking about the 5 shapes that are predicted by the theory, that is VSEPR theory. So basically, as in my previous lecture I have told you about the formation of the 5 shapes. So in this lecture we're going to discuss those 5 shapes in detail. So let's get started. First shape is known as linear shape. The shape is found in AX square types of molecules, which the central atom consists two bond pair. Now, I am repeating the previous lecture's point that this is called the bond pair, that are probably written as BP. And if there is formation of this kind of shape, that is known as lone pair. That is formed when two electrons are in connection with each other. So basically this type of bond where this one is known as A and these two bond pairs are known as X. So linear shape are formed when there is formation of AX square type of atoms. The equal atoms at 180-degree angles make a linear shape. Here we all know that whenever there is 180-degree, there is formation of pi. So here the pi is equal to linear shape. Now the examples of these kind of shapes is B, Cl2, C2H2, CO2, and these all things are included in that. Now let's move on to another shape. Secondly, we have another shape known as triangular planar shape. This shape is formed in AX cube. As we know, this is A and rest are X, so here it is AX cube, where the central atom possesses three bond pair. Now repulsion of these bonds form the three corner with of 120-degree. Now here keep that in mind, in linear shape there is 180. Whenever we are talking about triangular planar shape, there is formation of 120-degree. The geometrical, thus the development of triangular planars example can be BF3, C2H4, AlCl2 and more like that. Now another third shape is known as tetrahedral shape when the molecules are formed in the formation of AX4, where again we know that the central atom is A and rest are the X, where the degree is 109.5 degree. Now here the change is degree because of the repulsion, and that's what are the points of VSEPR theory. So here the formation of the A consists 4 paired electrons, means 4 bond pair, where the repulsion of 4 electron directed 4 X atoms to create a tetrahedron. Now examples of these kind of things are CH4 and C2H6. Let's move on to another shape. Now this is something really different and really fun. Now this is something known as triangular pyramidal shape, where there is one lone pair. This is cone-like shape with tetrahedral base and found in the molecules like AX cube E. Now here another term is used, AX cube. Now probably means that this is A and these three are X, where this is known as the E. Whenever you saw this kind of symbol E, so this represents a lone pair. So it is formed in the things that have 3X, mean 3 bond pair and 1 lone pair. Now this kind of atoms have degree of 107. And the example of pyramidal shape is NH3, PH3 with 3 hydrogen atoms. Since we know that hydrogen atoms are atoms which only needs 1 electron to complete their duplet. So this is why there is formation of the triangular pyramidal shapes in mostly hydrogen atoms. The last and the fifth shape is angular shape. Now angular shape is commonly found in angular shapes H2O, H2S, where there is formation according to AX square E2. Now here there are two bond pair and two lone pair that are surrounded by initially tetrahedral geometry in two ends of the tetrahedron, and two lone pairs make the corner that occupied the bond pair. Since the lone pair has the greater repulsion, so there is formation of the angle that is 104. And there is 0.52 that is mostly not considered. Now these were all four shapes that we have studied. Now let me repeat it, that in first linear shape the angle was 180. Okay, now mistakenly I wrote here 108. It's 180. In second one it was 120. In third one it was 107. In fourth one it was 109.5, and in the fifth one it is 104.5. Now these all shapes should be in your mind to actually solve the MCQs that are related to the shapes and the formation. I hope that you get this lecture, and this was the lecture that was based on the VSEPR theory and formation of the bondings. I hope that you get it, and thank you so much for watching.